you why I tell you to just do binary and just do decimal and be done with it. We've got 61 minus 50, what is that? 11. So if I write 8, 4, 2, 1, 0, oh, excuse me. 1, 0, 1. And there's my answer. And that's way better than this one's complement. So roll with that. But if you get into a job where your day-to-day adventure is doing this, again, come sit back down with me personally, because one, I want to know what job it is. And two, it really would be a little better. So 1, 0, 1, 1. Oh! How did we miss it? Let's go back and look. All right, so did I math wrong? 32 plus 16 is 48, 56, 61. Oh, we two's one complemented this one. I didn't use the original value. Bad trainer. So that is literally minus 8, that's 1, 2, 4, 8, 13, right? What's 61 minus 13? 61, 51, 48? 48. So 1, 2, 4, 8, 16. So that may be why our problem answer was wrong. 32. So I've got 1 here, 1 here. There we go. That's what it was a while ago. Yay, we did work it right. Anyway, binary works so much better. So that's 1, 1. I hate it when I work it right and then work it wrong. 0, 0, 0, 0. Yay. Multiplication, multiply. So let's see how they do it. I've got 101 times 111. 111 is 7. 101 is 5. I know the answer is 35. So I know I won't have a 1 followed by a bunch of zeros followed by 1, 1. So let's see what they get. My double noughts here. Oh, it just wants us to go ahead and answer that. Well, I hadn't even taught us multiplication. I was supposed to know that. Let's see if it really works like regular multiplication. Maybe I'm assuming too much. 101, 1, 1, 1. Yeah, this should be pretty easy. We do it the same way. So 1 times 101. Whoop, 101, excuse me. 101, right? So now we put our 0 here. 1 times 101. 1, 0, 1, right? Same way we do math. And then we put a couple of zeros. 1 times 101. Now add it all up. 1, 1. 1 and 1 is 0. 1 and 1 is 0. 1 and 1 is 0. And then 1. So this is 1, 2, 4, 8, 16, 32. 32 plus 3 is 35, and we said 7 times 5 is 35. So math works the same. Multiplication math, anyway. So it's 1, 3 zeros, and then 1, 1. And we could have done it either way, right? All right, let's do one more. 1, 1, 1. Times 1, 1. 1 times 111, 111. Right, the implied 0, 1 times 111 gives us 1110. 1. 0. 1. 1 and 1 is 0. And that's a 1. Everybody understand how I got that? So we did the 1, 1, 1. Times the 1, which gives us 1, 1, 1, we place our 0, do 1, 1, 1, 1 times 1, 1, 1, that gives us 1, 1, 1 with the implied 0. 1 and 0, 1. 1 and 1, 0. 1, 1, and 0 plus 1, 1 is 1, carry a 1. 1 and 1 is 0, you carry that 1. So let's see if it works mathematically. 1, 2, 4 equals, well, we need to go up here, don't we? 1, 2, and 4 equals 7. 1 and 2 equals 3, so it should be 21. This is 1, 2, 4, 8, 16. 16 plus 4 is 20 plus 1 is 20. So, just right. So 1, 0, 1, 0, 1. If we click in the box. Okay. Division. Let's let our heads work. All right, it's showing us this, 11 into 111. So subtract 11, and we put a 1. Yeah, that's working just the same. So we write this. That gives us a 1 up here, just as if we were dividing regular math, right? If that were 11 into 1111, our answer would be 101, right? So go to the next step. That leaves us with 0, 0, 1. 11 goes into 11 one time. Actually, 11 goes into 0, 0, 1, none. We bring down the other 1. 11 goes into 11, 101. Same thing here. 10 goes into 1100. Do a 10. Let's do it with a red marker so we can see. We write 10 here. That's a 1, right? That leaves us 1, 0. So 10 goes into 10 one time. That leaves us with 0. That leaves us with a 0. 10 goes into 0 how many times? 110. Yay! Real math, regular math. I like it. You can do it the same way regular math, take a 0 off. You could. All right. Who's ready for a test?
Shut
How
your
about a free
mouth.
test? It doesn't count me for anything. So that's what we'll do. Which number is not a binary number?
Hey.
A. All right, before we move, which of those numbers could be a hexadecimal number? Which of those numbers could be hexadecimal numbers? Any of them. That's right. Even 8 could be hexadecimal. Because as long as we see numbers between 0 and F, it could be a hexadecimal. But because we said 2 in that first one, it can't be binary. How about which of those could be octal numbers? All of them. That's right. I'm counting on us all to make 100 now. All right, which chart has the correct values in each column for decimal? D, the last one. This is not even binary. Lord knows what that is. Actually, C and D. No, isn't it D? It's C. What's wrong with D? It's got 0. That's the ones column. Trick. See, NIDA makes tricky questions, not just ones. So let's see. Which of those numbers is not an octal number?
B.
C. Want to hear one loud chime for y'all?
C.
Yeah.
Yep, it's C. A could be decimal, it could be octal, it could be hex, but it can't be binary. B could be binary, it could be octal, it could be decimal, it could be hex. C could be decimal, and it could be hexadecimal, but it can't be octal, because octal doesn't have an 8. And the last one could be any of those other than binary. Very Which number is hexadecimal?
No, big a third.
Is.
Okay, yeah, we have a G here, which is not there, H is not there, F is, K is not. 1111 to decimal. Quick. 15. 8 plus 4 plus 2 plus 1. 15. Octal number 732 to binary. D. Let's talk about why. Octal has to be in groups of 3. So it's 7 because we're talking about 4, 2, 1. 1, 1, 1. And then 30, 0. Oops, I'm writing up here in my 4, 2, 1 position. 4, 2, 1, 0, 1, 1. And then 2. I'm doing it again. 4, 2, 1, 0, 1, 0. That's got to be the last one just by the sheer quantity of numbers. Binary number 10111011 to hexadecimal. I got it. It would be B, which is BB. Because if we divide that in 2 groups of 4, you get 1011, 1011, which is a repeating pattern. 1011 is 11. The hexadecimal representation for 11 is B, so BB. All right. Choose your method to subtract the following binary numbers. I'm going to decimal. Y'all want to try one's complement? Feel free. Yep. 16. 19 minus 3. All day long is 16. So if we do have any subtraction or addition problems, binary in one sense is the way to go for subtraction. All right, 101 times 11. Simply write 101. We put a 0 here. We write 101 again. 1 and 1, 1 and 0. I mean 1 and 0, 1 and 0, 1 and 0, and 1 and nothing. Hey. Again, we can go to those binary equivalents. 4, 2, and 1. 4 and 1 is 5. 5 times 3 is 15. A is 15 because it's one shy of flipping over into the 16 place. So 8, 4, 2, and 1 give us 15. Divide the following numbers, 10 and 10, 10. So we can convert, or we can do just 10 and 10 gives us 1. That leaves us, I always want to write this on mine. That leaves us 1. 10 and 1 goes no times. But 10 and 10 goes 1. Put in D, 101. But again, we could do the math. 8, 4, 2, and 1, that's 10. Divided by 1, 2, that's 5. 1, 2, and 4, 1, 4, 5. So 10 and 10 gives us 101, or 10 divided by 2 in decimal gives us 5, which is 101 in binary. So 101 be, then we're gonna hold our breath and see if we made 100. If it is, I'm gonna give it all to you as a grade, it just won't count. No. That was mean, wasn't it? But it was sincere. We'll exit the quiz. Yay, we made 100. This quiz will have some other answers in it, so if you get into NIDA and want to play a little bit, you'll see some of these. If you want to revisit that one's complement and make your head explode, feel free. But again, it's not something you're probably going to see on test. Even if you do, convert it to decimal when you just do the math. I want you to understand how this works, and being able to do that is just as important in my mind as the one's complement is. And there's even a two's complement. So if you're having trouble going to sleep tonight, if you'll look up binary and two's complement, I guarantee within 15 minutes you'll feel ready to go to bed. Any questions? All right. So again, for those of you who we have added to NIDA and still can't get in, if you'll stick around, I'll try to help you log in and make sure we're doing that right. For those of you who want to get into NIDA to review this material, hadn't already seen Michelle to get that in, see Michelle, then come see me, I'll add you in. What are the two things NIDA has to have in order for you to log in? Before you even try to log in, let me show you that one more time. Because I'll go over this with my students at the beginning of the semester, and invariably I'll get an email, Mr. Lee, I can't get into NIDA. Are you using Internet Explorer? I was using Chrome. I want to use Chrome. I really want to use Chrome, but I can't with NIDA. So we've got to be in Internet Explorer. For those of you that have Windows 10, this is still a Windows 7 based machine. But if you come down here and type INT, you'll find Internet Explorer, even in Windows 10, it still exists. Edge will be down there, and E for Edge looks just like the E for Internet Explorer, but it's not Internet Explorer, it is Edge. So if you've got Windows 10, and you've got this E icon pinned to your taskbar, that is likely Edge, not Internet Explorer. And even though they're cousins, they don't work the same. It's got to be Explorer. So before I even try to press the login, if I do press the login, I can just close it. I want to go up here to compatibility, and I want to say compatibility view settings. And what would happen is you would see oftc.edu right there. You would have to click add, and then it would pop down here. And now I am truly in compatibility mode for that site. And all that is that there are people such as NIDA here who have not upgraded their means and methods for logins and this kind of stuff. And Internet Explorer provides a way to set back compatibility. Now, so do Chrome and Firefox and all those. But again, $5 bounty if you get it to log in under Chrome and Word. Under Chrome or Firefox, I'll give you $5 if you show me how, because I really want to. But it's got to be Internet Explorer for everything else. So any questions, anything we need to review? We've still got a few minutes if you're unclear on something. I see eager faces ready to go home. Y'all want to come back in and start on binary again tomorrow? All right, go home.